So for the first one is pretty okay, because now remember in secondary school what you learn is the fundamental theorem of algebra, meaning if the polynomial equation of degree of n, you have n roots. That is very important. So if it's a quadratic equation, you expect to have 2 roots. If linear equation, you expect to have 1 root because it's degree of 1. And if it's power of 3, you expect to have 3 roots and so on. Okay. But then you learn conjugate roots theorem. Conjugate roots theorem say that if all the coefficients are real, the complex roots will exist in pair. So 2, 0, 2, 0, 2, 0, 2. So you combine these two logics together. For cubic equation, it is only sensible to have either your roots are all real, or one pair of complex conjugate pairs and 1 real. Okay, you can never have three fake roots, 3 imaginary roots, because this has to come out in pairs, and you need to have 3 roots. Okay, so what does it tell you? It tells you it makes sense. Actually, it have to make sense with you. So if you think about the power of 3 roots, right? The cubic graph, it looks like that. Okay, cubic graphs looks like that or like that, right? It no matter how you draw it, right, it will definitely cut the x-axis one. It definitely have 1 real root one. This is 1 real root, right? This is 1 real root, right? If you draw this is 3 real roots, right? 3 real. There's no other way you can draw your cubic curve that it doesn't cut the x-axis. That is what it's trying to say. So cubic curve, this tells you that it definitely cuts the x-axis. If you want to really expound on it, you want to understand it, it means that you have to have 1 real root. No matter how you draw the cubic curve, right, you will always cut the x-axis. Okay, so they may ask you, explain why this equation will always cut the x-axis. You can just, it's the same explanation. So since this is what you write, I'm just going to type because it's faster. Since equation has all the coefficients are real, equation have more than two non-real roots. Complex roots will exist in conjugate pairs by conjugate roots theorem. Okay. Equation has a degree of 3. Thus, it will have 3 roots. Okay. You don't need to write the fundamental theorem of algebra in. You don't even need to write the complex. But I'll just write it down. Thus. Okay. Hence, cannot have more than two non-real roots. Cannot have more than 2 non-real roots. Hence, yeah, that's it. It can only have a maximum of 2 non-real roots. Yeah. So I write it. Okay. Given that z minus 7 is a root in part 1, so for part 2, just sub z equals to negative 7 into the equation. Into You can just sub in straight lah. Don't need to write this grandmother story here. So this is minus 7 cube plus a minus 7 square plus a minus 7 plus 7 equals to 0. Solve what is a. So this will be negative 7 to the power of 3 plus 7. That will be 336. And this is 49 minus 7. That will be 42a. 336 divided by 42. That will be 8. Okay. So this will be 7 cubed. Okay, basically, you have z plus 7 multiplied by a quadratic factor here, which is z squared plus bz plus c. You can put the a here, but then because this is 1, okay, we can just let a. That's it. Just compare the coefficients and you can get it. Yeah, okay. That's about it. Then you just solve it. You have to be clear how to solve it. You can do a long division. Definitely can do a long division. Maybe doing long division will be good. So let's just do a long division, z cubed plus 8z. Because it's easier, I think, instead of comparing. So just divide z squared, z cubed plus 7z squared. This is z squared. So this is plus z minus z plus 7 plus 1. Okay, so hence okay, then key in calculator. So this root here will be z equals to minus b, which is 1. Plus minus b squared minus 4ac over 2 times 1. Z is equals to minus 1 plus minus root 3 minus negative 3 over 2. Z equals to minus half plus root 3 over 2i, or minus half minus root 3 over 2i. Now, what does this mean? You have to be sensitive, huh? This means you can find the exact argument. The ratio is 1 to root 3, ma. The ratio is 1 to root 3. When the ratio is 1 to root 3, don't need to ask one. You just can find the exact argument. You have to know that, 1 to root 3. You can tell the ratio is 1 to root 3, right? This is a trade secret, lah. When you get 1 to root 3, you definitely can find the exact argument. Okay, so this ratio is 1 to root 3. Very quickly, I'm going to just quickly write down what is the argument for this one. This is root 3 over 2, then this is minus half, right? The argument here would be, this is pi over 6, right? Because this is root 3 here, this ratio here is 1, so it's 30 degrees, so negative pi over 6. Whereas for this one here, this is negative half here. Sorry, I used the wrong one. Never mind, I just do it properly. This case here, this is pi over 3. This is negative half. My goodness, here negative half. Then this is root 3 over 2. Here, this is root 3. This reference angle here is pi over 3. Because this length here is root 3. This is 1. Okay, so tangent will be root 3 over 1. So reference angle is pi over 3. Always take the positive reference angle. You are looking at here as 2/3 pi. Okay. So similarly, this is a conjugate pair. Conjugate pair. This obviously would be the other way around. Like it's basically reflection here, right? So this other one will be negative 2/3 pi lah. So this one have to make sure you can get it confidently. You cannot afford to lose marks here. This is not even a hard question yet. Okay, so minus the modulus will be the same. So this is just minus half square plus root 3 2 square. This will just be 4 over 4. So it's root 1. So this one here. So hence the other roots, right? You want in this form here. Other roots will be e I pi over 3 or e minus I pi over 3. Because the modulus is 1. REI theta. Okay. So that's e 2/3 pi by 2/3 pi. Okay. Now substitution is essentially trying to change it to the same equation. So a is 8 lah, so z cube. This is here. This over here is z cube plus 8z square plus 8z plus 7 equals 0. This equation here, I'm not sure what substitute I'm going to use. But always change the coefficient to the same coefficient. So what I mean by this is this negative 7, this is 7, positive 7, right? Change this to positive. Then you will see what the substitute is. Repeat, change this to positive. And especially for substitute for complex one, right? Complex substitution, what you need to know is I square is negative 1, I cube is negative I, and I to the power 4 is 1. All these things are basics. If you keep asking what are these, right? I really think that you should work on this, okay? So like I cube, right, is I square times I. This is minus I. There's no time for basic stuff really. If you can't really tell what is this, please go and review the lecture notes or do something about it, okay? So you cannot like, oh, when I tell you this, then you always say, hey, why is this going on? So this one's just take note, because I square is negative 1. Okay. So great. So once we're done already, my whole goal here is to change the coefficients to the same one. So this coefficient, my whole goal is to change this to 7, positive 7. Then my whole goal here is to change this to plus 8 if I can, because this is 8, 7, and 8. That is the whole goal there. So you always start with the constant. That's what I usually tell students to do. Start with the constant. So for part 3, you start off with the constant. That would be, let me just bring up my, let me just bring up my software, okay, here. And we'll start off with I z cube plus 8z square minus 8iz minus 7 equals 0. So this is 1. Then what I'm going to do next is I'm going to anchor this by using z cube plus 8z square. This is what I need to change to. The first thing I need to do is change this to negative, positive. So multiply this with negative 1. Then this minus 1, this will be minus iz cube minus 8z square plus 8iz plus 7 equals to 0. Okay. So once this is done already, I get, this is like playing what? I don't know what this is called. The mastermind. You just match. So 7 is done. So you see that this is 8, this is already 8, meaning to say this can be bracket like that. This is very likely a substitute really. Okay? Then if you are not very confident that this is positive 8, what you can do is actually rearrange this. This will be plus 8 minus z square. Alright? This actually, then same thing, you because you need it to be, bracket this. Then you need this to be 1z cube. So you just push it in. Don't care, push it in. Okay, like that. So you make the coefficient here 1. So you realize this, right, is actually minus iz cube. This is actually minus iz square. This is actually minus iz. And this is 7. It all started off by just changing this 7 to the same. That's about it. You just change the constant to the same one, you'll be able to tell the substitute is Isaac. That's about it. Okay? Typically, that's the case. So once you're done really, what do you want? I don't even know what we want. REI. Okay, great. So the other roots, right? The total roots. So sub Z as Isaac. Isaac is equals to, we have all the other roots. So negative 7 is actually 7 EI pi. EI pi is negative. So EI 2/3 pi. And then E minus I 2/3 pi. From here, you substitute here all these other roots here. This and this. So you, because they want in exponential form, guys. Exponential form. So you need to leave in exponential form. Alright. Then once done, I think the substitute once done, you need an exponential form. This needs to change to exponential form as well. I is EI pi over 2. You need to know that. And if you ask why, draw the Argand diagram. Please draw the Argand diagram. I is here. So this is pi over 2. This is 1 unit. Alright. So I is just EI pi over 2. So what I'm going to do here is I'm going to put this as EI pi over 2. Z equals to 7 EI pi. EI 2/3 pi. E minus I 2/3 pi. And Z is equals to 7 EI pi minus pi over 2. Because I divide. Okay. A lot of things to write. Oh. Okay. Then just key in calculator. So this would be negative 7 over 6 pi can add 2 pi. Please add 2 pi to be 5 over 6. This one here. Yeah. Okay, question asks